Section 4.1 is on page 251, talks about divisibility and modular arithmetic. So we start with the definition. If A and B are integers, so the key here is integers, and A doesn't equal to 0. We say that A divides B. A divides B. If there is an integer C such that B equals C times A. So if you could write B at the top as C times A over A, those cancel out. You're left with C. We say A divides B. That's the idea. If A divides B, we say that A is a factor or a divisor of B, and that B is multiplied by A. The notation A divides B denotes that what I just said, and if you put a line through it, that means it doesn't divide B. That means there'll be some remainder. So, for example, 10 divided by 5. So 5 divides 10. Meaning, I could take 10 and write it as a number times 5. In this case, it's a 2. And obviously, you could see that 10 is 2 times 5, and that's this part. Now, prove that if A, again, is an integer other than 0. 1 divides A. What does that mean? That means I could write A as 1 times that number. And that is true. And prove that A divides 0. Okay, A divides 0. That means I could write 0 as a multiple of A. And that is true. Therefore, there it is. We just proved it. That's just by the simple definition. Now, they denote this a bit more. They say let A, they define this a bit more. They say, let A, B, and C be integers and A not equal to 0. If A divides B and A divides C, then it says A divides B plus C. If A divides B and A divides, then A divides B times C. Well, that makes sense because B times C is an integer, right? And if A divides B, then any multiple of B is going to be divisible by A. And lastly, it says if A divides B and B divides C, then transition automatically A divides C. If A, so this is repeating what Dad just said. If A, B, and C are integers and A does not equal 0, such that A divides B, A divides C, then A divides a multiple of B plus a multiple of C, whenever those are integers, of course. And this is the last proof we're going to do. Show that if A, B, C, and D are integers and A not equal to 0, so suppose or let A, B, C, and D be integers, and A not equal to 0. Suppose A divides C and B divides D. Well, let's see. This indicates that C is A times M, or M is an integer. It indicates that let's end. D equal sum B times N. Well, if I take AB divides CD, well, let's see. If I take CD, wouldn't that be AM times BN? Wouldn't that be AB times NM? And if this is an integer, isn't that a multiple of that? So therefore, by definition, AB divide CD. Right? According to the definition, you could write it as a multiple of a value, as long as these are integers, and they are. So there it is. Now, let A be an integer and D be a positive. Let A be an integer and D be a positive integer. Then there are unique integers Q and R such that R is called a remainder and D is called D is a multiple, Q is a quotient. So if I take 44 and I divide that by 8, that is 5. Oh, not 0, 4. By the way, just to make sure that you understand this, the remainder can never be negative. It's always bigger than or equal to 0. So in this case, 44 is divided by 8. What does that mean? Well, find the quotient. The quotient is 5, and the remainder is, they use lowercase. The remainder is 4. There, really simple. When I get to this problem, it's a bit trickier. And why is that? Because if I take 123 and divide that by 19, well, that really yields a 6. And that is 114. Subtract the remainder of 9. The issue here is, I could say negative 123 is negative 7, is negative 6 times 19 minus 9. That will work, because 6 times 19 minus 9 is negative 125, but the remainder cannot be 0. So what we do, we boost this by 1. What that means, 7 times 119 oh boy, okay, I'm losing my track, give me 1 sec. I messed up on the 119 part, no wonder it's so big. So that is 63 and 7, 13, that's negative 133. To get to 123, you add 10. Again, remember, the remainder has to be positive. So in this case, the quotient is negative 7 and the remainder is 10. And we're going to do another one of those just to make sure we get it. If we take 100 divided by 101, well, that's 0 and a remainder of 100. The issue is, if you say, I'm going to take negative 100 and say that is 0 times 101, minus 100. Well, the remainder can be 0, so you boost this one up. That becomes negative 1 times 101. Plus 1 will give me negative 100. So here, the quotient is negative 1 and the remainder is 1. Now, a new way to write a quotient, they say the quotient is written as, if you're dividing, in the equality given in the division algorithm, D is called the divisor, A is called the dividend, AQ is called the quotient, R is the remainder. This notation is used to express the quotient and the remainder. If you say A div D, that's the quotient, and if you say A mod D, that's the remainder. So on the previous problem, I could say negative 100 divided by (101) yields, this is the quotient. The quotient in this case was a negative 1. And negative 100, not the other one, mod 101, remainder is 1. And that's how we do all of this. Again, another way of saying you don't need this anymore. Another way of saying, well, if I take negative 123 div 19, well, the answer in this case is negative 7, and negative 123 mod 19, in this case it's a 10. So remember, the remainder is always positive. And here we're going to play with those a bit. Again, let's do the positive first, because it seems we can see the positive a bit simpler. So if I take 10299 divided by 999 on my calculator, that's a 10. That is, if you subtract, you get 309. Well, what do they want? We want 1299 div 999. Well, what is that? That is a 10, the quotient. And 10,299 mod 999 is the remainder. The remainder is 301. As long as less than 999 we're okay. When we get to the negative, we do the same thing. We ignore the minus. Obviously, that's a 199. That is 12. Well, the issue is, we already know, you can't say, so basically what this is saying, it's saying negative 111 is negative 1 times 111 minus 12. Not negative 9 times 99. Oh boy, yeah, already messed that up. But this has to be positive, so what you have to do, you have to boost this by 2. And then that becomes a positive. And in this case, that would be 87. So 198 minus 87 gives you 111. Alright, and now if I want to say, well, what is A div 99 and what is 11 mod 99? So in the first case, what did we say it was? It's a negative 2 and it's an 87. So again, a fancy way of just mentioning those, which is the quotient and the remainder, div and mod. Now in programming, you could read that. If you're going to programming, you should pay more attention to that. And they talk about if A and B are integers and M is a positive integer, then A is congruent to B modulo M if M divides A minus B. Alright. a theorem says let a and b be integers and let m be a positive integer. A equivalent to b mod m if and only if a is mod m is the same as b mod m. Alright, shorthand of writing the same thing. Answered everything, yeah. So let's go about this problem. They're talking about military time. And how does that work? Well, military time works by 24-hour cycles. So in part A, I want to know what time is it going to be. So for example, if we work by 12 hours, if it is 11 o'clock now, 12 hours from now, it's 11 o'clock again. And that's how it plays. I want to start at 2 p.m. and I want 100 hours to pass by. Well, let's see. Let's take 100 divided by 24. That is 4. That is 96. Remainder of 4. So what does that mean? That means it's going to be 6 o'clock after 100 hours. How about if you have 45 hours before it reaches 12? For 45 hours, you would take... So here we want to know 45 before 12. So if we take 12 minus 44... Oh man, it's too late for me. And we mod that by 24. That would be negative 33 mod 24. And the same drill, if I take 33 divided by 24, well, that's a 1 for sure. And that right here will be 9. So again, I can't write the remainder as a negative 9, so I'm not going to say it's negative 33. I'm not going to say it is negative 1 times 33 plus 24 times 9. (24 times 1). Oh my god, what is wrong? So that is negative 1 times 33 plus 9, minus 9 to make the it's a bit late, so excuse me. It's negative 1 times 24 minus 9. That's the 32. So what we're going to do, we're going to boost this 1 up. That makes it negative 48. Remember, I do want to go back to two times 24 is 48 negative plus 15 will get me back where I want. So since that's a remainder, it would be 15.00. And if I want to go for C, let's do C right here. Okay, if I go for C, 168 hours after. So 168 hours, I'll go 168 and I divide that by 24. And of course, use a calculator for all of this. 7, 168, that's 0. Since the remainder is 0, it would read the same time. Alright. How about number 18? What do they want? Suppose that a and b are integers, and a is equivalent to 11 mod 19 and b is equivalent to 3 mod 19. Find an integer between 0 and 18 such that c is this actual mod. Well, a is 11 mod 19 and b is 13 mod 19. So I'll take 13 and I'll multiply it by 11 because that's what a is congruent to. Mod 19. Well, what is that? That is 143. If I take 143 and I divide that by 19, I'll get a 7. I'll have 10 leftovers. So in this case, C would be 10. And when I look at the next problem, not that complex. I have A and B right there. A is 11 mod 19 and B is 3. So if I take in, so this right here will be, well, A is 11 minus 3, which is 8. So that will simply be and that's because 8 is less than 19. Okay, next problem up. So here what are we dealing with? A is 11 and B is 3. So if I take this and I multiply it by 11 squared and 3 times 3 squared, that would be 209. And if I take 209 and divide it by 19, sorry, that was 200 and so 2 times 121, that's 269. And if I take 269 divided by 19, that is 14, and that will be 266. So I have a remainder of 3. So in this case, we will say 3 mod 19. Well, number 26, evaluate these quantities. We have a couple of theorems that say let m be a positive integer. The integers a and b are congruent. Module m if and only if there is an integer k such that a equal b times k times m. And where m is a positive integer. Let m be a positive integer if a is congruent to b mod m and c is congruent to d mod m as well, then a plus b is congruent to the sum and the product is congruent to the sum. I kind of used that really right here. Then I subtracted those. I should have put that definition before this, but that's where the definition applies. That's why I'm just plugging things in. Well, that should be C. Okay, so now evaluate these quantities. Negative 17 mod. So again, remember, if I take 17 divided by 2, that's simply 8. But if I say I have negative 17, and that is 8 times negative 2, that's negative 16 minus 1. The remainder can be 1. So what we do, we boost this one up. That makes it negative 24. Now from negative 24, if I want to go to 17, I would have to The 2 is fixed. I got it backwards. So it's negative 2 times 8. Okay, there you go. Now, if you boost this one up, you can't boost that negative 2. That 2 is there. If you boost the negative 2 up, that's negative 18 plus 1. So this will be 1. Remember, this is only the remainder. Div is the actual quotient. So if it's negative, you always have to go an extra step. But if it's positive, well, that's fairly simple. Take 144 and divide that by 7. Well, you need to do it by hand. You do it on a calculator. And if you take that, that turns out to be a 20. And I have a remainder of 4. So in this case, there's my answer, and I'm done. And that's pretty much it for this section. This case, eight minus 3 so this will be 11 minus 3. So that will be